So in this video, we're going to look at an example of differentiating an inverse trig function, and specifically we're going to look at an example that involves the inverse cosine. In the sequence of videos that are going to come next, we'll look at different examples involving different inverse trigonometric functions. So we'll just take them one at a time, and then you can choose when you feel like you know what to do and stop watching them. So the first one, we have f of x equaling the cosine inverse of 4x cubed. So we do have the inverse cosine function, and we know how to take the derivative of the inverse cosine function. The issue here is we have a function composition, so we have a third degree polynomial as an input to that inverse trig function. So when we take the derivative, we're going to need to use the chain rule. So one possibility for doing this would be to do a u substitution to make things look simpler. You do not have to do it this way. So we can, anytime we use a u substitution, it is almost always the case that we don't need to do it. It's optional. I'm going to do it in this particular case just to identify that you can simplify how the function looks by doing the u substitution. So if we rewrite the equation having done that u substitution, we get the cosine inverse of u. And then it has exactly the structure that we see here, the cosine inverse of a variable, and we can just apply the formula for taking the derivative that we developed in video. This one will be one that I develop in video 2 when it gets made. So f prime is going to equal, so we're going to get -1 over, and it's going to be the square root of 1 minus the input squared. So my input in this case is a u, so it's going to be 1 minus u squared because of my u substitution. But then we have to remember that we have to apply the chain rule. U is a function of x, so by the chain rule, we're going to have to multiply by u prime. And then once we've done that, we can substitute in for u here, -1 over the square root of 1 minus u squared. But u is just equal to 4x cubed times u prime. So that means replace u prime with its derivative from up here. So I'm going to take the derivative of 4x cubed is 12x squared. So we're going to multiply it by 12x squared, and then we want to do some simplifying. So we're going to get -12x squared in the numerator. Ooh, that's horrible. We're going to get -12x squared in the numerator all over the square root of 1 minus, where we need to square the 4, which is going to give us a 16. And then x cubed squared is going to be x to the 6. So we need to remember that when we raise an exponent to another exponent, we multiply the exponents. And I didn't. I said it but didn't do it. So it's going to be 3 times 2 is 6. We're going to have x to the 6th power there. And that's as simplified as you can get it. Notice I did say that you don't need to use a u substitution to do this. So we got cosine. I'm struggling with my writing here today. The cosine inverse of 4x cubed. So we could just as easily have said, hey, I'm going to take the derivative, f prime of x equals, and then I have my -1 over the square root of, and it's going to be 1 minus the square of whatever is in the cosine inverse function. In this case, 4x cubed is inside there. So I'm going to square that times, by the chain rule, I need to multiply by the derivative of the inside function, so times 12x squared, and then simplify just like we did when we did the u substitution. We get 1 minus 4 squared is 16. X cubed squared is x to the 6th. Pull my square root over the entire thing, and I probably want to move the 12x squared into the numerator position.